So let's have a look at a great little operator which is used extensively in coding and encryption, and that's the exclusive OR operator. So the operators we'll typically come across include AND. So with AND we take a 0 and a 0, we get 0, a 0 and a 1 gives us 0, 1 and a 0 gives us 0, and a 1 and a 1 gives us 1. OR is the next operator. A 0 and a 0 gives us 0, a 0 and a 1 gives us 1, 1 and a 0 gives us 1, and a 1 and a 1 gives us 1. Both these operators, when they're actually used, we will lose information whenever we operate on them with the AND and the OR. So it's very difficult to get the original data back again. The advantage with the exclusive OR as a bitwise operation is that we can actually get back our information again. So two operators which are typically used in encryption because they have this property of being able to get things back when we apply them again is rotate. So we can rotate left and we rotate right a number of bits. Where if we rotate left, then the bits will shift along this way, and the bits that come out at the end will go back into the start. So the advantage is that we can rotate left by 2 bits, and then the other side we can rotate right by 2 bits, and we end up with the same value. With exclusive OR, the binary table is a 0 and a 0 gives us 0, a 0 and a 1, just like when we're adding binary, gives us a 1 and a 0 gives us 1, and a 1 and a 1 gives us 0. Okay, so it's a bit like a binary adding function. So in this case we have a value here, 1, 1, 0 and so on. And let's take an exclusive OR value. This is a typical operator that's used for exclusive OR. And a 1 and a 1 gives us 0, a 1 and a 0 gives us 1, a 0 and a 0 gives us 0, and a 0 and a 1 gives us 1. So the great thing is that if we take the value that we operated on, such as say it was a key, if we do the operation now on this value, so these are the values that came from here, so that gives us 1, 1, 0, 0, just by taking these two values. And that's actually the same as our original values. Okay, so let's look at an example of this. Okay, so this is part of our exclusive OR coding. If you select this link, and then we'll take word, then we'll take a value. So to make it easy, we'll just take the letter T, and then that will apply an exclusive OR onto all of the letters with our special key. What you can see here is that the cipher stream doesn't actually display, so we can't actually see what the encoded value is, but when we check back and we exclusive OR with the same key character, we get the same plain text back again. And here's what the actual encoding has been. So our input, so the capital F is this, capital lowercase r, lowercase e, lowercase d, and the character T is encoded such as this. So we see that repeats, and we just use the same letter again and again. So a 0 and a 0 gives us 0, a 1 and a 1 gives us 0, a 0 and a 1 gives us a 2. Now we can see here that this character here and this one, along with this one, are all non-printing characters. So although the 2's came through, the other 3 characters in the encoded stream are not displayable. But we can see here if we represent it in hexadecimal, such as in this case, we have a 1 and a 0 for the hex string, then it can be displayed. And we can also display it in a base 64 format. Okay, so that shows how we can use an exclusive OR and you can try lots of different values. Okay, and we take the first character in this case, and we can see that's the string that it actually produces.